Before we begin this unit on moles and stoichiometry, we need to do a review of unit conversion and how to set up and solve unit conversion problems. The stronger your foundations are with unit conversion, the easier this unit will be. We start with a simple problem. If a cafeteria has 526 pairs of chopsticks, how can we calculate how many individual chopsticks are found in the cafeteria? Firstly, we need to find the conversion factor, which we multiply or divide our starting number by to change the unit. So, how many chopsticks are in a pair? As everybody knows, 2. Now, how do we use the conversion factor? We need to look at our units. The final unit we want is chopsticks, so we need to cancel the unit pairs. As we know, when we divide any number by itself, it cancels out. The same thing applies to units. Therefore, when we write the conversion factor with chopsticks in the numerator and pairs in the denominator, then multiply the conversion factor by the number of pairs, the unit pairs cancels out, and we're left with the number of chopsticks, which is 1052. The two examples below require multiple unit conversions. Firstly, the Great Wall of China is the longest artificial structure in the world by far. In this question, we want to find the length of the Great Wall using an old Chinese measurement, the li. If we know that 1 li is approximately 500 meters, we can find out the length of the Great Wall in li. However, our initial measurement is 21,196 kilometers, so we can't do this conversion directly. However, we can use a second conversion factor, 1,000 meters is equal to 1 kilometer, to solve this. Firstly, we can multiply the length of the Great Wall by 1,000 meters per 1 kilometer, then use the second conversion factor, 1 li per 500 meters. Based on how the units cancel, we can see both kilometers and meters in both numerator and denominator, so they both cancel, and we are left with the final measurement in li. If you calculate the answer, it comes to 42,392 li. For an extreme example, we're going to look at eggs. If we know that China produced 24.1 billion tons of eggs in 2013, and a standard medium egg is 49.6 grams per egg, how many dozen eggs were produced in China in 2013? This calculation requires a number of conversion factors. Firstly, since our starting measurement is in tons and the mass of eggs is measured in grams, we need to convert tons using the conversion factor 1,000 kilograms per 1 ton. Then convert kilograms using the conversion factor 1,000 grams per 1 kilogram. Now that our measurement is in grams, we can figure out how many eggs we have using the conversion factor 1 egg weighs 49.6 grams. However, our question didn't ask for the number of eggs, it asked for dozens. Since we know 1 dozen is equal to 12 eggs, this is our final conversion factor. If we check our conversion factors, we see that everything except for dozen is cancelled. So we multiply everything together and find our final answer, 4.05 times 10 to the 13 dozen, or 40.5 trillion dozen eggs. That's a lot of eggs. In the next video, we'll look at how conversion factors can be used in chemistry-related calculations and learn about the most important conversion factor in chemistry, the mole.